Hey guys! Welcome back to the laboratory. In this video, we are looking at endothermic and exothermic reactions. By the end of this video, you should be able to describe the differences between endothermic and exothermic reactions, explain the energy changes during endothermic and exothermic reactions, and use reaction profiles to demonstrate the energy changes during endothermic and exothermic reactions. So, let's go! During any chemical reaction, energy is exchanged between the reactants and the surroundings. When the chemical bonds between the reactants are broken, energy is taken in from the surroundings. And when chemical bonds are forming between the products, energy is released into the surroundings. In an endothermic reaction, heat energy is absorbed from the surroundings, causing a decrease in surrounding temperatures. The word endothermic can be broken down to describe the process, with en meaning to enter, and thermic relating to heat. So the word quite literally translates to enter heat. An example of an endothermic reaction is electrolysis. This concept of endothermic reactions can be quite tricky to understand. So let's break it down in a bit more detail. Now remember, during every single chemical reaction, energy is taken in from the surroundings to break bonds, and energy is released into the surroundings when making bonds. If the amount of energy taken in from the surroundings to break chemical bonds is more than the amount of energy released when new chemical bonds are formed, then the overall reaction is endothermic. For example, if a chemical reaction gains 465 kilojoules of energy from the surroundings to break bonds, but only loses 204 kilojoules of energy to the surroundings when new bonds are formed, then overall, more energy was taken in from the surroundings to break chemical bonds. The overall energy difference of the reaction is positive, meaning the reaction has gained energy, and this is therefore an endothermic reaction. In an exothermic reaction, heat energy is released into the surroundings, causing an increase in the surrounding temperatures. Once again, the word itself can be broken down to describe the process, with ex meaning to exit and thermic relating to heat. So the word itself literally translates to exit heat. An example of an exothermic reaction is combustion. Once again, in an exothermic reaction, energy will be taken in to break bonds and energy will be released to make bonds. However, the overall reaction is exothermic because more energy is released into the surroundings when making new bonds than is taken in to break them. So, for example, if a chemical reaction takes in just 116 kilojoules of energy to break bonds, but releases 384 kilojoules of energy when making new bonds, then overall, more energy was released to the surroundings to form chemical bonds. The overall energy difference of the reaction is negative, meaning the reaction has lost energy, and this is therefore an exothermic reaction. We can use reaction profiles to reflect the energy changes that occur during endothermic and exothermic reactions. On a reaction profile, the energy stored in bonds is represented using a horizontal line. The higher the line, the more energy stored in that bond. The reaction profile for an exothermic reaction would look something like this. Because the overall energy change throughout the course of the reaction is negative, the reactants at the start of the reaction are going to have had more energy than the products formed at the end. So, in this reaction profile, we can see that the energy stored in the reactants is high. Then we see the energy falling as it is lost to the surroundings to form new bonds. And here we have our products, which are now storing less energy than the reactants. In contrast, the reaction profile for an endothermic reaction would look something like this. Because the overall energy change throughout the course of the reaction is positive, the reactants at the start of the reaction are going to have less energy than the products formed at the end. So, in this reaction profile, we can see that the energy stored in the reactants is low. Then we see the energy increasing as it's gained from the surroundings to break bonds. And here we have our products, which are now storing more energy than the reactants. We can represent the activation energy on a reaction profile as a hump. The activation energy is the minimum amount of energy required for a chemical reaction to take place. Here we have the reaction profile for an exothermic reaction with the activation energy included. Remember, in an exothermic reaction, the reactants are already storing a great amount of energy. Because of this, only a small amount of energy is needed before the activation energy is met and the reaction can begin. This is then followed by a large loss of energy to the surroundings as the reaction progresses. In contrast, we can see the reaction profile for an endothermic reaction. This time, our reactants are storing smaller amounts of energy, and so we see that a large amount of energy is needed before the activation energy is achieved and the reaction can begin. A small amount of energy is then lost to the surroundings as the reaction progresses and the products are formed. In both profiles, we see the overall energy change is marked as the difference between the energy of the reactants and the products. Here's an example of a past paper question that I'd like for you to attempt to test your understanding of the content covered in this video. Pause the video and take your time to work it through. Press play once you're ready to check your answers. When zinc reacts with copper sulfate solution, zinc sulfate solution and copper are formed. An experiment was carried out to measure the temperature change when zinc powder reacts with copper sulfate solution. The initial temperature of the copper sulfate solution was 20 degrees Celsius. The final temperature of the mixture after the reaction was 46 degrees Celsius. Explain what the temperature readings show about the type of heat change that occurs during this reaction. This question is a nice, easy one. The only thing I would emphasize to you here is the importance of the word explain in this question. This means the question wants for you to make a point and then support that point with an explanation and/or supporting evidence. This is how you are going to achieve your 2 marks. Make sure you back up your answer. So we can see here that there has been an increase in the temperature of the mixture, meaning that heat energy has been released into the surroundings, and thus the reaction is exothermic. Remember, exit heat. Guys, this is your answer. So, for the first mark, you would state that the reaction is exothermic. Our second mark is for then explaining how we know this, backing up our answer. We know this because the temperature of the reaction has increased. Or, if you're feeling fancy, then you can even state that the temperature has increased by 26 degrees Celsius. This is your second mark. That's it. So, how did you do on this question? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!